All right, we're going to do some absolute value inequalities. We're going to solve them, and then we are going to get to graph them on a number line. So our steps are up there in green. First thing we have to do is isolate the absolute value. That means get it all by itself. So first thing, we're going to add 6 to both sides. So we get greater than or equal to 13. Now, it's an absolute value, so we have to set up 2 cases. What's in the absolute value might be positive or it might be negative. Now, this is an inequality, not an equation, so we're going to have to keep the old flip and switch in mind. So first thing, 2x plus 3, well, sure, it might be greater than or equal to 13. Or, case number 2, 2x plus 3, the old flip and switch, might be less than or equal to negative 13. You have to flip the inequality and change the sign. We've got 2 cases to solve for now, so when we subtract 3 from the other side, here's what it looks like. Looks like one of our solutions is x is greater than or equal to 5. On the other side, when we subtract 3, looks like this. Our other solution is x is less than or equal to negative 8. So these are our 2 solutions. And when we go to graph them on the number line, remember, these have an equal sign under the inequality, so we're going to have filled in circles. X is greater than or equal to 5. I'm going to go to 5 and fill in my circle, and all the solutions greater than or equal to 5 are to the right of 5. I'm going to go to negative 8 and put a closed-in circle because it is less than or equal to, and all the x's that are less than or equal to negative 8 are to the left. So that's one way to graph it, is with your number line. Now, another way that we can express our solution is in interval notation. For one thing, it might really impress your friends, but it also might be on your SOL. So I like to look at the graph and remember that negative infinity is out this way, and positive infinity, of course, is this way. So when I make my interval notation, I remember that some of these solutions could be from negative infinity to negative 8. I'm going to use a bracket because negative 8 is included in the solution. It has an equal sign. Or, I'm going to use the or symbol. The rest of my solutions are from 5 to infinity. Again, I'm going to use a bracket around the 5 because 5 is included. It has the equal sign. Now, this is an or, so my solutions, my arrows on the number line are going in opposite directions. You're going to like this. Greater. When you have a greater inequality, then you know that you're going to have an or where the arrows are going to point in opposite directions. Now, keep in mind this step right here. If you divide both sides by a negative at any point, you have to change the direction of the inequality. We didn't do that here, so let's go on to the next example. All right, the next one looks like this. We have to isolate the absolute value first. That means get it all by itself. So we're going to have x minus 3 is less than 4. It's absolute value, so we're going to have to set up 2 cases. X minus 3, yeah, it could be less than 4. But the other case, we're going to have to do the old flip and switch. X minus 3 might be greater than negative 4. The old flip and switch, you have to flip the inequality and change the sign. Once we solve these inequalities, I'm going to add 3 to both sides here, add 3 to both sides here. So my solutions are less than 7 and greater than negative 1. So if you think about that, it's all the x's between these 2 numbers. When I go to do them on my number line, I'm going to find negative 1. I'm going to do an open circle because this one did not have any equal sign. And I'm going to find an open circle above 7. Open circle because it did not have an equal sign. And the solutions are between these numbers. The solutions are between these numbers. This is an and. An and will always have the line in between the 2 solutions. We could also write in an interval notation. My solutions are all found between negative 1 and 7. And I'm going to use parentheses instead of brackets because there's no equal sign. Now, on this one, make sure